To answer this question, we need to rearrange the equation to find the value of x. So what that means is that we want to find the value of x that if we substitute it in, will make the statement true. Now, this is quite a simple equation, and it's more than possible to solve it just by inspection or trial and error. So what we need to do is say, okay, what minus 4 would give us a value of 2? Well, 6 minus 4 would give us a value of 2, which means the answer must be 6. So you might be wondering, well, what are these other boxes for? What do I need to rearrange it? It's not so much for questions like this, but as algebra formulas get more complex, it's really important to have a system or a rule or a procedure to allow you to rearrange them to find the value of x when you're not able to figure it out just by inspection. And so to teach this, we start with the simple equations, and once you've got the rule or method down, you can then use it to solve more complex equations. And the idea behind it is the idea of inverse operations. What I'm talking about there is opposite operations. So the opposite of addition is subtraction. The opposite of subtraction is addition. The opposite of multiplying is dividing, and the opposite of dividing is multiplying. So this little table here shows you the inverse operations for our 4 basic operations. To undo addition, we subtract. To undo subtraction, we add. To undo multiplication, we divide. And to undo division, we multiply. So in this particular question, we're dealing with subtraction. And the problem we've got in terms of finding out the value of x is that at the moment, we've got more than just x itself on this left-hand side of the equation. We've got x minus 4. And in order to get x on its own, we need to take this minus 4 and move it to the other side of the equation. But this is where inverse operations comes in. When you move something past the equals in a maths equation like that, it changes the operation to the inverse operation. Let me show you what I mean. We've already got a 2 on this side of the equals, so we can put that into our first answer box. Our last answer box is going to contain the 4. But this one here is not going to contain a subtraction. It's going to contain the inverse operation to subtraction, which is addition. So let's put a plus into that box and complete the question. And we can now see the method works because 2 plus 4 is equal to 6, which is our correct answer. Let's try another one. So this time we're dealing with multiplication, but the same sort of method applies. We need to take that times 5 and move it over to the other side of the equals, where it will become the inverse operation, which is divided by 5. So we already know that 25 is on the right hand side of the equation, so we can put that in there. And then instead of multiplying by 5, we'll divide by 5 to find the final answer. 25 divided by 5 is 5, and if we put that into the last answer box, that completes the question. Let's look at another one. So this time we're dividing by 2 on our left hand side, but the method stays the same. We first put in 4, because that's what we've got on the right hand side of our equals, and then we'll move the divided by 2 over to the right hand side, where it becomes multiplied by 2. 4 times 2 is 8, and if we put 8 into the last answer box, that completes the question. Let's just look at one more involving addition this time. So this time we've got a question where x plus 3 equals 6. So we'll put down the 6 in our first answer box, because that's already on the right hand side of the equation. Then we'll take the plus 3 and move it to the other side of the equals, where it becomes minus 3. And then to find our final answer, all we have to do is 6 minus 3, which gives us 3, to complete the question.